Hello students, this is the next problem under model 3, the problem under beta coefficients or loss coefficient. In figure shown, a system having two sources designed as plant 1 and plant 2 connected to node 1 and node 2. Okay, there are two nodes and network of 5 branches, 1, 2, 3, 4, 5. The reference voltage of 1 at an angle 0 per unit is indicated in the diagram. It is indicated here. V3 is 1 at an angle 0. The branch current and impedances are given: IA, IB, IC, ID, IE, ZA, ZB, ZC, ZD, ZE. Here this is R, this is X. So this is RA, XA, RB, XB, RC, XC, RD, XD, RE, XE. So this is the problem given. Okay, here two plants are connected. One plant is connected to bus 1 and other plant is connected to bus 2. Okay, bus 3 and 4 comes in between 1 and 2. There are 5 branches: A, B, C, D, E. Okay, and 5th bus and to the 6th bus loads are connected, 2 loads, L1 and L2. We will solve the problem. First at node 1, okay, we have to calculate voltage. Why we need to calculate voltage? Because we need to find the value of phi 1. Okay, in order to find the value of phi 1, okay, we need to find out the value of the voltage at node 1 as well as current. Okay, so V1 is equal to, by looking at the circuit or diagram, okay, so V1 is equal to, okay, it is V3 plus IA into ZE, correct? V3 plus IA into ZE. So it is V3 plus IA into ZE. V3 it is given 1 at an angle 0. IA it is 1.2 minus J 0.4. ZE it is 0.02 plus J 0.08. Just substitute, okay, substituting and solving, we get almost 1.056 plus 0.088 J. Okay, so we have to convert it into polar form. When we convert it into polar form, we get 1.059 at an angle 4.76, okay, per unit, 4.76 per unit. Similarly, V2, okay, V2 which can be calculated like this, which is V3 plus IC ZC, okay, here current direction is opposite to IC, so minus IB ZB. I repeat, V2 is equal to V3 plus IC ZC minus IB ZB. So substituting everything, okay, V3 1 at an angle 0, IB 0.4 minus J 0.2, ZB 0.08 plus J 0.32 plus IC 0.8 minus J 0.1 into 0.02 plus J 0.08. We get 0.928 minus J 0.05. Okay, converting it into polar form, we get 0.929 at an angle minus 3.08, okay, 08 per unit. So no need to calculate V4, okay. I1, next we need to calculate the value of I1. I1, by looking at the network, we can say that I1 is equal to IA. I1 is equal to IA, which is equal to 1.2 minus J 0.4. Converting it into polar form, we get 1.265 at an angle minus 18.43, correct? So I2, here By looking at the circuit, we can say that I2 is equal to IC. IC is equal to 0.8 minus J 0.1 per unit, correct? So converting it into polar form, we get 0.806 at an angle minus 7.125 degree, okay, 725 degree per unit, okay. So here sigma 1, it is the angle of I1, correct, and sigma 2, it is angle of I2. Why sigma 1 and sigma 2 are required? Because two planes are connected. So cos of sigma m minus sigma n is there, correct. In formula, beta mn is equal to cos of sigma m minus sigma n, so on. So m is a plant 1, okay, n is a plant 2. So there are two planes, so we need to calculate the value of sigma 1 as well as sigma 2. So sigma 1, it is the angle of I1, sigma 2, it is angle of I2. So sigma 1 is, it is angle of I1, which is minus 18.43. Sigma 2, which is angle of I2, which is minus 7.125 degree. Okay, and phi 1, okay, so denominator, beta mn formula denominator has cos phi m into cos phi n. Here m is equal to 1, okay, 1, and n is equal to 2 because two generators are connected. So we need to find out the value of phi 1 and phi 2. What is phi? It is a angle, right? Cos phi, it is a cosine of the angle between voltage and current, correct. Cos phi, which is the cosine of the angle between voltage and current. So phi is phi v minus phi I. So phi 1 is equal to phi v1 minus phi I1. So phi v1, it is angle of v1. So it is 4.76, okay, 4.76 minus phi I1. Phi I1 is angle of I1, which is 18.43. So minus of minus 18.43, substituting we get 23.19. So what we need is cos phi m into cos phi n on the denominator, that is cos phi 1 and cos phi 2. So we need to find out the value of cos phi 1. So cos phi 1 is 0.9192. Okay, similarly phi 2, it is the angle between phi voltage as well as current, phi v2 minus phi I2. Okay, phi v2, it is minus 3.08 minus phi I2, which is minus 7.125. So minus here, okay, minus of minus, it becomes plus. So adding both, we get 4.045. So what we want is cos phi 2 on the denominator of beta mn formula. So it is equal to 0.9975, okay. Power factor, it is 0.9975. Next, power P1 is equal to V1 I1 cos phi 1, okay. V1 is equal to what? Okay, it is the magnitude of V1, it is 1.059. Okay, magnitude of V2, it is 0.929. Magnitude of I1, which is 1.265. Magnitude of I2, which is 0.806. Okay, and phi 1, cos phi 1, which is 0.9192. Okay, cos phi 2, 0.9975. Substitute everything in that equation. So we get, on solving, we get 1.059 into 1.265 into 0.9192, which is equal to 1.23 per unit. Okay, it is 1.23 per unit. Similarly, P2, which is V2 into I2 cos phi 2, V2 is 0.929 into I2 is magnitude of I2 which is 0.806 into into cos phi 2 it is 0.9975. The answer is 0.746 per unit. Okay, so we got P1 as well as P2. Let us find out the value of beta Mn. In order to find out the value of beta Mn, we need current distribution factor value also. Okay, so let us consider two cases. In first case, we will consider plant 1 supplies the demand alone. Okay, so plant 1 supplies the load alone. When plant 1 supplies the load alone, the plant 2 is out of operation. Here there should be open circuit, right. So when there is a open circuit, okay, current through this branch which is I2 is equal to 0. When this current is 0, IC will be 0. Okay, IC will be 0. And here you can see IA is equal to ID plus IE. IB is equal to IE. Okay, IB is equal to IE. So IA is equal to ID plus IE. So here L1 and L2 are two loads. So load current ID, total load current ID is equal to I suffix small d plus IE. Okay. So ID we know, ID is 0.8 minus j 0.2, IE is 1.2 minus j 0.3. So we get 2 minus j 0.5, correct, 2 minus j 0.5. Okay, and current distribution factor which can be defined, which is the ratio of current in the branch to the total current in the load side. Okay, current in the branch to the total current in the load. So MA1 is equal to current in the branch. Okay, current in branch A which is IA divided by total current in the load side which is ID. Okay, so IA divided by ID. IA is what? ID plus IE. ID is what? ID plus IE. So both cancels. It is equal to 1. Here IB is equal to IE. Okay. So IB is equal to IE. The value of IE which is 1.2 minus j 0.3. Okay, magnitude of that we want, divided by ID which is magnitude of 2 minus j 0.5. Okay, we get 1.2 minus 0.3i divided by 1.2 minus 0.5i. Okay, converting it into polar form, we get 0.6. MC1 which is equal to current distribution factor at branch C which is equal to IC divided by ID. IC value which is 0, so which is equal to 0. MD1 which is equal to ID divided by ID. Okay, ID value which is 0.8 minus j 0.2. Okay, magnitude of that plus divided by 2 minus j 0.5 magnitude. So we get 0.8 minus 0.2 I by 2 minus 0.5 I, we get 0.4. Okay, so ME1 which is equal to IE divided by ID. Okay, we know that IB is equal to IE. Okay, therefore these two are same, so we get 0.6. Okay, we have calculated MA1, MA2, sorry MA1, MB1, MC1, MD1, ME1. Now we need to calculate MA2, MB2, MC2, MD2, ME2 by keeping plant 2 operating alone. Okay, consider case 2 where generator 2 alone operates and G1 is open. When G1 is open, current through which is I1 is equal to 0. When this current is 0, IA is equal to 0. Okay, when IA is equal to 0, okay, here IC is equal to I2 which is equal to ID plus IE. Okay, ID plus IE. Here in actual network IB direction is reversed. Okay, but here current supplied by the generator 2 when generator 2 alone supplies the demand, right? So current direction has to be reversed. So IB is equal to minus ID. Okay, by looking at this, IB is equal to minus ID because we are going we have reversed the current direction. So IC is equal to ID plus IE. Okay, IC is equal to ID plus IE. Also we know that total demand ID is equal to ID plus IE. So MA2 is equal to, it is current distribution factor which is current in the branch, okay, A which is 0 divided by ID which is ID plus IE which is equal to 0. Okay, next MB2 which is current in the branch B IB, okay, by ID. IB is ID with the value of which is 0.8 minus J0.2 divided by 2 minus J0.5. Okay, it is 2 minus J0.5. Okay, so answer is 0.4. Okay, answer is 0.4. Okay, here we have considered minus, right? So here we have considered minus of this which is minus 0.4 only. Okay, minus of this is minus 0.4. Similarly MC2 which is equal to, okay, IC divided by ID. IC is ID plus IE, okay, and ID is ID plus IE, magnitude of that, okay, which is equal to 1, okay, which is equal to 1. Similarly MD2 which is ID divided by ID which is same as that of this one, okay, so it is 0.4. ME2 which is IE divided by ID, IE is how much? IE is 1.2 minus J0.3, okay, divided by 2 minus J0.5, magnitude of that, okay, which is equal to 0.6. So we have calculated MA2, MB2, MC2, MD2, ME2 here. Okay, so now we need to find out the value of beta Mn. The loss coefficient formula beta Mn which is cos sigma m minus sigma n summation mkn whole divided by Vn magnitude cos phi m phi n. But we know that m is equal to 1 and n is equal to 2. Okay, considering beta or B11, okay, which is equal to cos phi 1 minus phi 1, okay, summation, okay, K varies from here A to E, right? A to E, and MA 1 square, because M is equal to 1, okay, M is equal to 2. So MK 1 square into RK whole divided by V1 square cos phi 1 square. Similarly, B22 or beta 22, which is equal to cos sigma 2 minus sigma 2 summation mk2 square into rk whole divided by v2 square into cos square phi 2. So expanding, we get cos sigma 1 minus sigma 2, which is equal to 0, cos 0 which is equal to 1 into ma1 square into ra plus ma2 square into mb1 square into rb plus mc1 square into rc plus md1 square into rd plus me1 square into re whole divided by v1 square cos square phi 1. Everything we have calculated, okay, ma1, mb1, mc1, md1, me1, and also we have ra 0.002, rb 0.08, rc 0.02, rd 0.03 and re 0.03. Substitute everything, okay, and calculate the value of beta 11. We get 0.0679, okay, 0.0679. Similarly, beta 22 or B22, which is equal to cos sigma 2 minus sigma 2, which is cos 0 is equal to 1. So into ma2 square ra plus mb2 square rb plus mc2 square rc plus md2 square rd plus me2 square re whole divided by v2 square cos square phi 2. Simplifying, we get 0.056, okay. Similarly, beta 21, which is equal to beta 12 or B21 is equal to B12, which is equal to cos sigma 1 minus sigma 2 into ma1 ma2 ra plus mb1 mb2 rb plus mc1 mc2 rc md1 md2 rd me1 me2 re whole divided by v1 v2 cos phi 1 phi 2. Everything we know here. In first term here ma2 is 0 and mc1 is 0, okay, so this will be 0, and here mb2 is minus, okay, minus 0.4. So we get final answer minus 3.9135. Now we need to find out the value of PL, that is transmission loss. PL is equal to P1 square, this is two plant system, so P1 square B11 plus P2 square B22 plus 2 P1 P2, beta 12 is equal to beta 21, so or B12 is equal to B12, so 2 P1 P2 B12. Substituting everything, we get PL is equal to 0.128 per unit.